Welcome to Chris Gumi online mathematics lesson. Today I'm here live at Glory Digital Academy at Christ Apostolic Church opposite Jake Filling Station, Sabo, Kaduna. That is Sabo before bridge if you are coming from town, or Sabo after bridge if you are leaving Sabo. If you are in Kaduna, you can visit the church to be admitted into the class. But if you are living outside Kaduna, you can private chat me. Thank you. In our last class, we looked at elimination method. Today we are looking at substitution method. And you remember we said simultaneous equation has another name that is called systems of equations. So it is said to be system of equation or simultaneous equation. And we said for simultaneous equation or systems of equations, when you have two unknowns, you're supposed to have two equations. If you have three unknowns, you're supposed to have three equations. Is that okay? And in our last class, we said because it is linear, if the simultaneous equation is linear or the system of equation is linear, it means that the power of x and y here the highest power must be 1 for it to be linear. If it is, and this x is said to be the independent variable, whereas this y is said to be the dependent variable, because the value of this, you must get the value of x for you to find the value of y. But what we are saying is that for it to be a linear equation, the power of these two unknowns must be 1. Is that okay? And we said for linear, you have a straight line. If you have a Cartesian plane like this, this is 0, this is my y-axis, and this is my x-axis. We said assuming you have line. So this line will be the line of a linear equation. The other one will be the second line for linear equation. And we said that where the two lines meet, let's assume this is y1 and this one is x1. We said the coordinate here, which is this point, is x1, y1. We said that is the solution of that simultaneous equation. And as we have explained before, we said if you solve this one using elimination method, you are going to find the value of x that will be here, and the value of y that will also be here. So, but if that simultaneous equation does not have a solution, it means that this point of intersection will not exist. That means that simultaneous equation does not have a solution. Another thing that we also say is, we said if the lines are parallel, for instance, you have something like this. As for the two equations, as this one is parallel to this, we said that simultaneous equation has no solution. Is that okay? Has no solution. And the way to notice it is the gradient will be the same. So if I have y is equal to mx plus c, where this m is my gradient. Now, for it to be parallel, it means that their coefficient will be the same. So for instance, now if I have y is equal to 3x plus 2, and I also have y is equal to 3x minus 5. If you look at this one, their coefficient is the same with this. So that means this type of linear equation is parallel. Why is it parallel? Because the coefficient, which is the gradient m here, the m here is 3, and here too is also 3. Is that okay? And another way again is that you should know is that it must be in this form. Because for instance, this equation that we have on the board, if I have x plus y is equals to 12. For me to express this, to know the gradient, I must make this the subject. So y will be equals to minus x plus 12. So that means my coefficient here is minus 1. The same thing true for this one. I have 3x minus y is equals to 20. If I want to transform it to be in this form, where I will make y the subject, I will transfer this from the left hand side to the right hand side. I have minus y is equals to minus 3x plus 20. Is that okay? So I have to remove this minus here. So for me, I multiply both sides by minus. So I have y is equals to 3x minus 20. So that means the coefficient here, which is the same thing as this one, m, is 3. So if you observe this one, the coefficient is, that's the gradient now. The gradient is 3 and the gradient is minus 1. That shows that type of simultaneous equation or system of equation is not parallel, because their gradient here is 3 and the gradient of the second equation is minus 1. It will be parallel when the gradients are the same. Another last point that we said from the last class is that infinitely many, in a situation where you have the lines intersect each other. The lines intersect each other. If the line intersect, then you have a straight line and you have another straight line on it. If you observe, the line intersect at different points. So we say it will have infinitely many solutions, and that kind of simultaneous equation, you will have something like, maybe I have 3x minus 2y is equals to 20. Another form that will be infinitely many is that when I have 6x minus 4y is equals to 40. So this and this, they are the same. Just that this is a multiple of this. Is that okay? So because they are the same now, it will be that they intersect at different points. So they have infinitely many solutions. Now let's go back to our substitution method. Now look at it. We said the first thing you have to do, just like the way you do it in elimination, you have to number your equations. So this one will be equation 1. This one will be equation 2. Why are we numbering them? For reference. We are numbering them for reference. You want to make reference to any of the equation, then you use the number. Is that okay? So what is substitution method? As we said, elimination method is to have one of the unknown to become 0. Now in this substitution, we are supposed to pick one of the equation and make subject of one of the unknown. And when you do that, then you substitute back to another equation, not the same one that you carry to make subject. But to follow it up, let's look at it. So we want to solve it. So here now, so let me ask, which one should we pick to make subject? If you look at here now, this equation 1, it's easier to make y the subject. In this, and it's also easier to make x the subject. So you have two options here in equation 1. Equation 2 is easier to make y the subject, even though it's negative, than making x here the subject. Is that okay? So I'm asking the class now, which one should we carry to make subject? Equation 1. If you know the answer, you raise up your hand. So here we are saying, so here we can say that from 1, or using 1, from 1. So here we can say x plus y is equals to 12. So y will be equals to 12 minus x. Here now we have made y the subject. In other words, we have expressed y in terms of x. Is that okay? So this one now you number it to be equation 3. Is that okay? So since we are using 1, then that means we are substituting the value of y into 2. Take note, into 2. Not to use, you are not supposed to use this one. If you use this one, I'm going to give you 0. So if I use this one, I'm substituting the value back to this one. If it is this one that I use, I'm substituting the value into this one. Is that okay? Since we are using this one now, we are putting the value into this other one. So here I will say substitute y equals to 12 minus x into 2. Is that okay? So I have 3x. Now this equation minus y is equals to 20. So I want to replace this y now with 12 minus x. Take note there's a negative here. This one does not have negative. So I can write like 3x minus, I'll put bracket. So I have 12 minus x close bracket is equals to 20. Any question here? Any question? So let me ask, why is it that we decide to put this minus in bracket? And you know, we put in bracket and there's no any bracket in the question or in the one we have solved. Who can tell us why? Why is it that we decide to put bracket and there was no any sign of bracket in the things we are doing? Why do we put bracket? Yes. Yes.
Because 12 minus x is the same thing as y, so just like put it inside the equation. Just put 12 minus x instead of putting y.
I didn't get what you said.
Sir, because when you substitute, when you form the equation, it says y is equals to 12 minus x. So now when you're now putting back into equation 2, instead of putting y, you put that 12 minus x. So that's why you now enclose inside a bracket. So like,
okay. Okay. What's another idea? Yes. Okay, I think this one is more appropriate. Clap for 2 of them. Because take note, this is positive here. And you know you have a negative here. So when you want to replace this one, you know it's only this one that is being replaced. And since it carries a negative sign, that negative will affect these terms. You know there are 2 terms here. You have 12 and you have minus x. So that's why you have to put a bracket showing that this minus, which is minus 1, will times this plus 12. Minus 1 also times this minus x. Is that okay? And you know when you are doing times, when you are solving times, you know, for instance, if I have minus 3 times minus 2, what is the answer of this? Plus 6. So when you are doing the times, you are performing your normal times, but the sign, those sign table, you are putting it because minus times minus will give you a plus. Is that okay? So 3 times 2 will give me 6. So in other words, minus 3 times minus 2, the answer will be plus 6. Is that okay? So the same thing we are happening here. So we put this negative, we put this in bracket so that this negative will transform this or it will multiply this term. Is that okay? So here we're going to have 3x. So minus 2 times 12 will be what? Minus 2 times 12. Minus 12. It will be minus 12. So minus 12. Minus 1 times minus x to be plus x. Okay, here did I say 2? It's not 2 here. I'm supposed to say minus 1 times 12. Is that okay? There's a minus 1 here. So minus 1 is times a plus 12. Give me a minus 12. Minus 1 is times a minus x. It will give me a plus x. So here I'm going to have equals to 20. Is that okay? Now let's look at. So we want to simplify the left-hand side. This and this are like terms. So when this and this join together, give me 4x. So I have 4x minus 12 is equals to 20. Is that okay? Yes. So I'll collect like terms here. I have 4x is equals to this minus 12 will leave the left-hand side. Go and multiply like term here on the right-hand side. I'm going to have 12 plus, 20 plus 12. So 4x is equals to 32. So I'll divide both sides by the coefficient of x to find my x. So x is equals to 32 all over 4. So x, 2 here, 2 here, 16. And 16 divided by 2 is 8. So that means the value of x is 8. Is that okay? So this value of x, because already in equation 3, you have already expressed this y in terms of x. So just going to substitute, instead of going, even if you substitute it here and here, it will still give you the same answer. But it's always easier to substitute it inside equation 3. Is that okay? So substitute x equals to 8 into 3. So here now we're going to, or let me ask, why are we substituting x equals to 8 into 3, not into 2, not into 1? Who can help us with the answer? Yes, you that is last. Like you want to give the answer. Yes. We are asking that why is it that we are substituting it inside 3, the value of this x, instead of in this one and in this one? Why not this one and this one? Why is it that it is 3? Do you know the answer? Yes. What's your name?
My name is Joshua. Because y is already being solved to formula. Since we're looking for y, we should just
Very good, clap for him. So, we are saying that y has already been expressed in terms of x, or in other words, y is made the subject of the formula. So that means once you put in the value of x here, you can be able to know the value of y. So here we're going to say substitute into 3, and our 3 is y is equals to 12 minus x. So y will be equals to 12 minus 8. So y is equals to 4. Take note, I said put it in coordinate form. So we're going to have coordinate form. We have x, comma, y. So here we have 8, 4. So that is the value of x and y. Is that okay? So that is all about substitution method. What does it entail? We said when you have two equations, you pick one of them that is convenient for you to make one of the unknown the subject. When you do that, you substitute into the other equation. Then you see that the unknown will be the same. Then you go ahead and solve it. When you solve it, you find out unknown. Then substitute the unknown into 3. In other words, that means in substitution method, you have 3 equations, except if it's complicated. You always have 3 equations, and you are supposed to substitute the value of the unknown that is found in equation 3 to find the other unknown. And substitution method is the one that is general. You can use it to solve any system of equation or linear equation than elimination method. Because elimination method, some critical questions, some questions that are complex, you will not be able to survive using elimination method. Or substitution method can help you. So in other words, it's better to know substitution method. But just that in some situations, elimination is easier to find the unknowns than the substitution method. Did you get what I said?
Yes, sir.
Let me repeat what I said again. It's not all systems of equation that you can use elimination method, but all you can use substitution method. Now, what you have to do for me, do you remember that example 1? I'll see post in the platform. That example 1, or that question 1. that we have solved before. The one we started solving before, the one we solved, that we did correction today. The one you're going to use substitution method, following this pattern or following this concept that I have displayed here on the board to solve it. Is it clear? Yes. And you are submitting it. You are submitting it before Monday. You don't want this work to carry. You don't want this work to affect your normal academic work. It's Monday. That means Sunday midnight. Is Sunday midnight not convenient? Sunday midnight. Or should we add Monday into it?
Yes, sir.
To add Monday?
Yes, sir.
So okay, let's put Monday. Is there anybody that cannot solve it before the end of Monday next week? You cannot say it, because once you have accepted now, I will not check it if you send it. I will not check it if you send it. So Monday is okay.
Yes, sir.
So the deadline, yes. You won't be able to solve it. So which day is convenient for you? So okay, somebody is saying Monday is not okay, so let's leave it. I hope we are not saying you should solve all the questions, and tell other people that are not here. Don't go and solve all the questions. No, it's not all the questions. Only that question one. That question one, and we have already solved it, or you have already solved it using elimination method. The answers are there. So what is it I'm going to check? I'm going to check you are supposed to number the equation. I'm supposed to see question 3. And I'm supposed to see you finding one of the unknown here.
Yes, sir.
And then substitute into equation 3 here. You get this one. Then put them in coordinate form. These are the things I want to see. Is that okay?
Yes, sir.
Yes. Thank you, and you have a nice day. So that means when you have finished this one, I discover that most of you, I will do the correction. After the correction, then I will see whether we should continue function, because the next topic is function. If it is not well done, maybe I will have to come and explain that substitution again before we enter function. And all these questions, we'll go ahead and solve them after this particular one. I will give you. Is that clear?
Yes, sir.
Yes. So thank you.
Yes, sir.
Yes, you can clap.